Hello. Good morning. It's good to see you all. I know it's a little dark in here, but I promise the sessions in here will not put you to sleep. They're very, very good, and I'm very excited. And I'm very excited to have you all with us back for another year in Bonn. For anyone who doesn't know me, Chris shouted me out on stage, which is always lovely to see your face up on the screen like this. But I'm Emily Medemo, the managing editor of Automotive Logistics, and it's great that you're joining us for the finished vehicle focus sessions that we have. So earlier this morning, we definitely heard from, a range of supply chain leaders, how they're taking a bigger role in shaping more strategic decisions across the automotive industry and really, truly to unlock every value. So we also heard that logistics and supply chain providers also play a critical role in enabling those strategies too. So for this session, we're going to be zooming in on the logistics side of that conversation, specifically now the outbound side. And we'll be focusing our conversations by kicking off with a keynote from Volkswagen Group around how digitalization is opening up new possibilities for operations planning, decision-making, and network design. So to lead us through these insights, please welcome Peter Hernlein, Managing Director of Vehicle Logistics at Volkswagen Group.
Thank you. Thank you, Emily. Hello and good morning, everybody. It's great to be here in Bonn, and it's really nice to be here in the dark with you, but maybe we have an enlightening discussion afterwards, and I'm happy to share a couple of insights with you. So welcome to a little trip into the future of what we think might be some future aspects of vehicle logistics. I'm not going into a company presentation, don't worry, but just a little information up front. As you might know, we are in charge of distributing all the finished vehicles for the entire Volkswagen Group, all brands, with the main focus on European traffic and overseas traffic from everywhere to Europe, from Europe to the world. We do not touch US for US, we do not touch China for China. So in total, that amounts to between 4 and almost 5 million vehicles per year. And we are connecting our plants with more than 150 markets and working together with almost 1,000 partners, service providers, shipping lines, trucking companies, and so on. And in various discussions with our colleagues and partners, we find out that we all face more or less the same challenges. We are in a very dynamic market environment. The flexibility, the volatility is really great. Ups and downs we see all over the place. Geopolitics plays also a nice role in that one. We also see that there is a shortage of skilled workers, so it will become more and more difficult in the future to find skilled people to move cars, to transport cars, to load trucks. And we all experience that also the logistics space is not unlimited, and we have to make very efficient use out of that one. And there is some ideas how to optimize that in future or how to get a better grip on these challenges. So the first aspect I would like to share with you is what we call Autolog at our own port in Emden, which is basically really making a shift of automated driving in vehicle logistics. And then unfortunately, we have to do a little theory up front. I'm specifically not talking about autonomous driving. That's what you read in the press. That's where every OEM is working on to bring the cars to level 4, level 5, which is really then the desired functionality for the end customer. But there the intelligence and the sensors sit inside the vehicle, and it will be still a way to go until we see a valuable amount of cars being equipped with that technology. What we are talking is automated driving, where we make use of external infrastructure in order to steer the vehicle in an automated way on a logistics yard. As I said, it's a pilot project, it's a research project, and we cannot do that on our own as Volkswagen. We are teaming up with some partners. So there is Unikey providing the vehicle operation or the vehicle management software. There's Deutsche Telekom providing a 5G network. And we have also scientific support from the BIBA Institute in Bremen. And literally, you can think of the setup like this. We have equipped the whole area with LiDAR sensors, which if you transfer it to human body, is the eye. The sensors overlook the situation constantly and send signals to the brain. The brain is the vehicle control software in the background that's provided by our partner Unikey from Finland. And that basically makes a permanent comparison what should be based on the task stage and what can the lidar see what is really the case. And they react on it and send signals to the car in terms of accelerate, pull the brakes, go left, go right, stop. And basically the car is then the muscle executing the tasks that the brain gives them. And the 5G network is more or less the central nervous system to really connect every aspect of that. And yeah, we think it really bears a lot of potentials, not only in profitability, because you do not need any drivers anymore to operate these cars, but also in scalability to move up the volumes in our own areas, but also in other compounds or ports we are using, and also to transfer it to other partners, to other areas, or to other aspects of the business. But enough of the theory, maybe let's have a little glimpse into reality, how that goes. That's our port area in Emden, and you see here vehicles that are driverless because they are driven remotely controlled. We have installed a test field there with LiDAR sensors, and we perform a lot of tasks like parking, like reshuffling cars, getting them out of rows, and especially also making them interact with manually driven cars. For sure, we are also looking at the safety side of it. And as I said, the results so far are very promising because we can really perform all sort of complex maneuvers, all sort of complex tasks in the test area. And our strong belief is that we can scale it up and roll it out. In order to be able to do so, two aspects are very important from my side. For sure, everybody has its own operating system in the background. Everybody has own solutions there, and there is nothing wrong about that. But we somehow need a standard communication interface to that remote vehicle operating system in order to basically give the tasks and what should be done. And then there should be also, or there has to be also a standard communication between the vehicle operating system and the vehicle backend, the car itself. For the second aspect, there is already an ISO communication standard in place where I can really only preach that adherence to that is crucial in order to scale the whole setup up. For the other one, we are for sure working with our partners in order to help defining these communication standards. Also to face reality, currently there are not too many suppliers of remote vehicle operating systems, so I'm really convinced it should be able to talk them into the same standard and to define a standard which can be then used all over the industry, because that's key to scale it up. Why I'm stressing that topic that much? If you look at that technology from our point of view offers really a big potential, not only on the own plant yards in order to get the cars out of the factory, but also at ports and compounds where multiple OEMs meet with their cars. And you could also transfer it to any other aspects of the business, whether it's yard logistics, whether it's depot logistics, for buses, for parcels, for rental cars that need to be reshuffled. So I think there is a lot of opportunity in order to make use of that technology and make more efficient use of space and workforce. Once that is in place, from my perspective, this is not really the end of the road. And what we are also experimenting and starting now is that we say, okay, can we rethink yard logistics or vehicle movements on the yard in a completely new way? And we are now introducing a reinforcement learning AI-supported tool in order to develop a parking strategy or in order to optimize the parking maneuvers. And if you give today's situation, you take the car, you park it somewhere, then it sits there, and then you take it again before it's loaded on a train, on a vessel, whatsoever. Disrespectfully, I say that's the past. In the future, we will see ongoing games of Tetris on the yard because you can reshuffle these cars all the time in an automated way to bring them in the best position in terms of space utilization, in terms of shortening driving distances, in terms of pre-sorting them, in terms of moving them already in batches for destined markets. So that's another aspect where once the technology is in place, you can put it to the next level and really give it another push in terms of efficiency. And talking of AI, I think that also bears a lot of potentials. And at the moment, my team is trying to apply AI solutions. If you look at that simplistic picture of the vehicle logistics chain, every little star here indicates where we are currently experimenting and testing AI solutions or AI-supported solutions in order to make processes more robust, more stable, more efficient. And I just want to really pick on two little ones. One is that we are working on forecasting models, which is extremely important on the new car side, but it's even more important on the used vehicle business side because there the cars pop up more or less randomly, or it's very hard to predict where they will pop up. And that AI model or AI-supported model helps us a lot to improve the demand prediction. And with the pilot project we are running there, it was in a relatively short period of time possible to increase the accuracy by 8%. And imagine what that means, that you can apply your capacities, assign your capacities in a much better way. And also then, especially in the used car business, when these cars pop up based on the specifications, based on the age, based on the mileage, it will be also possible to predict in a much better and more precise way in which regions, in which areas these cars are most likely to be sold. And then you can also assign the capacities, you can move them to these areas where they are sold earlier, and therefore make efficient use of capacity and shrink the timing. And another one that's a very little one, as you might know, we have a system called Outbound Order Book, which is our communication tool or tool where we transfer the orders to our especially trucking company service providers, which jobs are to do. And whenever there is some question marks on the system or some hiccups, we have now a support bot in order to reduce the support costs, because the first level support is basically done by an AI agent in order to make sure is the system used correctly, is there a mistake in the background. So that's a very small solution, also making the use of that more efficient. And as you can see, there is a couple more examples where technology can help, where technology can maybe help to reinvent some of the processes. This morning in the round table, I have said vehicle logistics in itself has not changed that dramatically over the past 20 years. I think now there is more and more technology coming on where there could be a step change and they could move it to the next level. And I hope I could give you a couple of thoughts and a couple of ideas what that might be. I'm looking forward to the panel discussion to come up, and I think that might be an enjoyable ride into the future of vehicle logistics. Thank you very much for your attention.
Thank you so much, Peter.
Thank you.
Thank you. Thank you so much. So we're just going to slightly reset the stage here for the panelists to come up. But while we do that, Peter, I want to come to you with a couple of questions. There will be chances from the audience to ask Peter some questions as well. So we will get to those if you have some. But I just wanted to ask, coming straight from your presentation there, you showed how Volkswagen Group has introduced new technologies across areas from the port terminal handling through to network-wide planning. So now that you're kind of through some of the pilot stage and pilot planning, what has been some of your biggest takeaways since those changes were implemented?
Yeah. One of the biggest takeaways from our pilot or research project in Emden was really the interaction of these automated driven vehicles with manually driven vehicles, which is the real big majority, And also what we think or what we envision might be the interaction in the future when you also then see autonomous vehicles coming along. So from that perspective, automated driving is not really something for the end customer at the end of the day, but it will, from our point of view, be a very important technology to bridge that whole time span from now until we see, and I'm not sure when that will be and how much we will see autonomous vehicles all over the place. And it's really nice to see them interacting. You saw in the movie that roundabout in our test field. We have taxis going on with 6 drivers on board with a manual driver. We have cars that get driven manually by an individual driver. We have these automated driven cars, these remote controlled cars, so to speak, also sorting themselves in the line, interacting with them. We made a lot of safety relevant tasks in terms of can they do an emergency stop if you throw a cardboard box in front of them or if somebody walks into the driveway. And that was really a big finding, that is say in relatively short time that technology has come to a very good and acceptable level. And from that point of view, I'm also convinced that you can really scale that and transfer it to other areas.
Perfect. Thank you, Peter. Please join the panel and we'll get into a lot of those areas a lot more.